All right, good afternoon. We are going to talk about climate systems and weather today and kind of what the difference between those two terms are and how they interact with one another. So the very first thing, if I didn't show you this in class, is to watch this intro video. It's going to kind of give you an insight into the difference between climate and weather. It's funny and it's, just kind of a lighthearted way to introduce this system or these terms. All right, so the first thing I want to talk about, and please, everything in blue needs to be written down in your notes, is that first kind of statement on the top of your screen right now. Studying climate involves long-term trends. So when we're talking about climate, we're talking about 20 to 30-year periods, not a year, not 5 years, 20 to 30-year periods. Okay, so if you look at this, we can look here. This is a block period, right? That's about 50 years or so. Okay, so over this period of time, we can see that the climate increased, then it decreased, then it increased in temperature. And we can say that in that period of time, the climate has, in general, increased in temperature. And we've seen an increase change in the climate system. Okay, and then you can see that again, even though there's been periods of decrease, right? If you looked at the data from just here to here, you would say, well, the climate is decreasing in temperature. But in reality, if you look at the entire graph, it's evident that the climate changes in the last 100 years have been pretty dramatic increase in temperature. Okay, so when we're talking about climate, it's 20 to 30 year periods, and you might have down or changes that are opposite of the overall trend that you're seeing, but that doesn't matter in the overall scheme of things. Okay, so why are climate systems important? So climate systems determine the weather, and we'll talk about what weather is and that in a second. And that obviously affects our daily decisions, but climate also affects long-term decisions by humans, whether or not you have air conditioning in your home, if you own a car or a bike. All of these things are things that, based on the climate and the climate of where you live, are going to affect some of your long terms, what your house is made out of, things like that. And it also affects long-term trends in plants and animals. So if we look, okay, what plants have survived in Colorado versus maybe the climate in Kansas or the climate in Indiana, those are obviously very different climates, especially if you look at like a jungle climate or a climate on the equator, right? That's going to, animals in those areas are going to respond very differently than animals in Colorado. And that would be based on climate. So that's why climate systems are important. Let's talk about weather specifically. So weather refers to the state of the atmosphere in a particular place and time. So this is short periods of time, typically days to weeks max. And predictions can only be over a week, where we can look at a climate model and we can make predictions for the next 50 years based off of previous data. It's just not possible to do that with weather. Okay, so when we talk about weather, we're talking about sun, wind, snow, rain, all of those things. And weather is simply an expression of the climate system, which we'll talk about in a second. That has to do with a lot of different pieces. But the fact that it's warm today, that's an expression of the climate system. It doesn't necessarily describe the climate system. It's just a result. Right now, it's really cold in the north east. That is an expression of the climate system and a change that's happened in the climate system that's resulted in that weather. Okay, what I'm going to have you do is kind of look at this graph. This is temperature versus month, and it's over a year. Okay, so think about what the X and Y axis are, what individual points on the graph represent, what do the two colors represent, what trend in the thick lines, what is the trend in the wavy lines, and then what lines do you think represent weather and which ones represent climate. I'm going to have you answer those in your notebook right now. Sorry, pause it and then answer it, and then we'll move on. All right, the next conversation we want to have is, what are the controls and contributors to the weather that we see? So we're going to talk about air mass movements. We're going to talk about global winds. We're going to talk about unequal solar heating and how do they affect the options or the plethora of weather that we may experience from a day to day. Okay. So as a review, energy radiation from the sun hits Earth's surface, right? So radiation is anything from the sun that transfers its energy in the form of maybe visible light, UV ray, IR to the surface. And then the surface is heated through conduction at that point. Okay, so incoming solar radiation that reaches Earth is called insolation. And so that's how much of the sun's energy actually reaches the surface. So hopefully this is intuitive, but it's most intense at noon on June 21st if you're in the northern hemisphere near the equator. Okay, so that's the most intense sunlight because it's the most direct. As far as like how much solar radiation reaches the Earth, so about 19% is absorbed by clouds, 30% is reflected by clouds or the Earth's atmosphere, and then 51% is used for condensation, evaporation, infrared radiation, and conduction and convection. So energy is transferred away from the Earth's surface by radiation, evaporation, water condensation. So ultimately, depending on how much radiation is actually hitting the surface, that is going to have an effect on the weather that we're observing, because the more it absorbs, the more maybe condensation and evaporation is going to happen. And that would potentially lead to greater storms. Okay, so we're going to kind of look at that, but know that depending on how much incoming solar radiation is absorbed, that is going to dictate and influence the weather that we see. So there's this term called unequal solar heating of Earth's surface. And this is just heating that's caused by radiation from the sun, and it's unequal due to the angle it strikes the Earth. And you guys understand this. It's just kind of putting terms to your previous knowledge. So in the summer, radiation is more perpendicular and direct, heating the northern hemisphere of the Earth. Okay, that's what makes it summer. It's more direct, so it's warmer temperatures. In the winter, it's at an oblique angle, which causes less heating. So if we look at this, this is the winter, right? And you can kind of see this. If you make a line, this is going to hit this at a oblique angle, where here you can see so much more is exposed and able to receive the direct light from the sun. And so this is really unequal solar heating is where we get all of our seasons. So it's due to the tilt of the Earth, not the rotation. It's due to the tilt. And so if the tilt is basically pointed away in the northern hemisphere, that is when you have winter. If it's pointed towards, that's when you have summer. And then with that, you also get kind of this unequal solar heating, not just in seasons, but across the globe. So obviously energy is more concentrated at the equator, where more visible light is able to hit it directly. As visible light comes in here, it hits it more at an oblique angle. And so you don't see as much energy or heat at the poles. It doesn't matter like where on that line you are. Latitude doesn't matter, latitude matters, not longitude. Okay, one other piece of this puzzle is called air mass movement. Convectional lifting is really what we've been talking about this whole time. That's the circular motion of air. Orographic lifting is when an air mass is pushed up over an obstacle. And the big thing here is that it can cause a rain shadow. So rain shadows are areas of dry regions with little precipitation. And the reason for that is they would occur on like this side of the mountain. So what happens is you have this warm air and it rises. As it rises, it starts to cool down and it condenses. And it condenses into clouds, which then obviously drop their rain once they get heavy enough. So they drop their rain on this side of the mountains, and then the cool air that isn't having any moisture in it continues this way, and you're left with a rain shadow because there's no air, or there's no moisture in that air. So this is really what's happening in Fort Collins and Denver and Colorado Springs, is that on the western slope of Colorado and in Summit County, places like that, there's a lot of precipitation and a lot of moisture in the air. But as you kind of go over those mountain ranges, that precipitation is dropped, and what's left in Fort Collins is really depleted of its moisture. And so we have a significant rain shadow on this side of the mountains. All right, you are going to look into global wind patterns and how global winds affect and change and play into this conversation about weather and weather patterns. And then you'll look at air mass movements. We'll kind of reinforce some of the things we've kind of introduced today. And then you'll be done with this unit. So if you have questions, raise your hand. Otherwise, you can move on to your next assignment.